Everybody feel good about their dishes today? I did. Yay. Fantastic. Super yummy. Simple. Easy. That's
Okay, good morning, everyone. Okay, sorry for being late. I was giving an exam for another class, so I wasn't able to quit on time. Okay, today is, as you guys know, mainly a review for tomorrow. So I would like to start by the homework I've assigned, and then I will go to the review. And the best way to do it is to take your questions and proceed. So please go ahead. What questions do you have about the homework first? So first the homework, and then the review. Please go ahead. Mark number 13. And any other questions from the homework? Okay, 13 and 22. Okay, so we will start with 13. So number 13. So we have the, okay, I'm reading all your problems. I'll put them up and I'll try to go through all of them because basically today is just actually a review for tomorrow. So we'll do number 13 first. And the question is, sorry, use differentiation to find a power series representation of the function f of x equal. So we have the function f of x equal 1 over 1 plus x to the power 2. And the question is, find a power series representation using differentiation. It means basically they want us to start with a series that we know and differentiate it to get to that. So which series we have to start with, and what I expect you always, I mean, of course, you're going to have your notes tomorrow, so that's not a big deal. But the series that you will be able to use to figure out power series of other functions will be 1 over 1 plus x, you can use, 1 over 1 minus x, you can use, ln of 1 plus x, you can use, and arctangent x, you can use. So those you can use to figure out the power series representation of other functions. So this one, 1 over 1 plus x to the power 2. Which is the natural series I'm going to start with to get to that one. So quickly, either write it down on chat or unmute yourself and tell me what will be the natural one to start with. I'm listening. Yeah, absolutely 1 over 1 plus x. So I'm going to start with 1 over 1 plus x. And I'm going to relate it to this function. So before I proceed and find its power series, I'm going to relate it. So what is the derivative of 1 over 1 plus x? And let's see if they are relatable, which is they will be. So 1 over 1 plus x, that's 1 plus x to the power minus 1. I need to find its derivative. So that's minus 1 times 1 plus x to the minus 2 times the derivative of what's inside, but derivative of 1 plus x, it's 1. So this is minus 1 over 1 plus x squared. So this is a very good sign. It means this function is nothing more than the derivative of that, but there is a minus that I have to take care of, which is not a big deal. We will take care of that. So the idea is we're going to start with 1 over 1 plus x, write up its power series with its radius of convergence. It means for which values of x the whole thing holds, and then we go from there. So I'll start with 1 over 1 plus x. And this is equal to 1 minus x plus x squared minus x cubed plus dot dot dot. And in sigma notation, that's sigma minus 1 to the n, x to the n, and my n go from 0 to infinity. And this equality holds as long as I take in x less than 1 in absolute value. Now we're going to differentiate. And if this is the power series of 1 over 1 plus x, the power series of its derivative is obtained by doing term by term differentiation. So the derivative of that equal. Now I'm going to differentiate term by term. Derivative of 1, it is 0. Derivative of minus x is minus 1. Plus derivative of x squared minus the derivative of x cubed. It should be plus the derivative of x4 plus etc. So this is going to be equal to sigma term by term differentiation minus 1 to the n, derivative of xn is n times x to the n minus 1, term by term. And now my n goes from where to where? Now this is n equal to 0, but if n is 0, the term is constant, so from 1 to infinity. Even if you put it n equals 0, for n equal to 0, this is going to give me 0, so it won't affect anything. And this holds for the same value the original one holds for. Okay? Now, what's the derivative of that? The derivative is minus 1 over 1 plus x squared. Okay, so this is equal to minus 1, so I'm just differentiating. The derivative is that plus 2x minus 3x squared plus 4x cubed, etc., etc. And for x less than 1. Now I want 1 over 1 plus x squared, so I have to multiply across by negative 1. So I'm going to basically switch the sign. 1 minus 2x plus 3x squared minus 4x cubed plus etc., etc. Which is going to give me in sigma notation minus this right here. So that's what's going to give me. So we're going to multiply this by a minus. So I'm going to have minus the sum of minus 1 to the n x to the n minus 1 from 0 to infinity, from 1 to infinity. Now we can bring the minus inside. And if I bring the minus inside, what will happen? The minus 1 to the n is going to increase by 1 and x to the n minus 1. And this holds when absolute x is less than. Does that make sense? Okay. Yes, good. Now, the second one, part B, is actually the same. I may not do it all over again, but I'll definitely tell you what is really going on. So this is page 1, because I like to scan those and basically put them on Blackboard. And page 2. So part B, so let me write part B, and I'll just give you a guideline. So part B is use part A to find the power series for 1 over 1 plus x to the power 3. So part B, they want you to find the power series of that. Okay? Again, they want you to use the previous one. They want you to use the power series of 1 over 1 plus x squared. And does it make sense? How can I relate those to each other? Okay. What's the derivative of this? That's 1 plus x to the power minus 2, the derivative. So it means minus 2, 1 plus x to the power minus 3, which is going to give me minus 2 over 1 plus x to the power 3. All right, so the derivative of this function is equal to that. So now I'm going to repeat the same process. I'm going to start with that one, write up its power series. So I'm just going to write up the few terms. I will not go through the whole process. So this is going to be right there. It's 1 minus 2x plus 3x squared minus 4x cubed, etc. So now I'm going to differentiate term by term. So I'm going to differentiate this. And this is equal to the derivative of that. 1 goes away, minus 2 plus 2 times 3 minus 4 times 3 times 4, 12x squared plus so on. It means that if I take minus 2 over 1 plus x to the power 3, this is going to give me minus 2 plus 6x minus 12x squared and so on. Now, I just want 1 over that. So what should I do? I want a quick answer. I want 1 over, but here I have minus 2. So what should I do across the board very quickly? What do you want me to do? Divide by minus 2 across the board. So I can get, so divide by minus 2. And then I get it. 1 minus 3x plus 6x squared, and so on and so forth. Okay, so that's how we handle this. The idea is that, again, I'm emphasizing the idea we deal with those power series really, really like polynomials. And that's why they are very easy to work with. All right. Any questions about number 13? All right, so I'll move on to number, let me pick them up. Which one you guys asked? Number 22. Okay, so let's look at number 22 and see what the difficulties were. So number 22. All right, so what this is about? 2022. Okay, they want us to find the power series of the following function. So I have f of x equal ln of 1 plus x to the power 4. Okay, very good. Now, how are we going to do that? We're actually going to start with something that we've seen. And I repeat, the power series that we've seen are 1 over 1 minus x, 1 over 1 plus x, ln of 1 plus x, and arctangent x. Those are within, we can use them. So obviously here, I'm going to start with ln of 1 plus x. You don't have to derive it. You can use what we know. So obviously, that's the one we have to start with. So ln of 1 plus x. So let us see what is, we did that, and let us remember what did we get when we did that. And I'll try to, I should memorize that. So ln of 1 plus x is going to be equal to x minus x squared over 2 plus, as I said, you can use that, x3 over 3 minus x4 over 4 plus etc. And in sigma notation, that's sigma minus 1 to the power n minus 1 or n plus 1, it doesn't matter, xn over n, where my n goes from, I want it positive, so we're going to go from 1 all the way to infinity. Okay, and this holds when absolute x is less than. Okay, now I want ln of 1 plus x to the power 4. So I'm going to just substitute x4 for x. So now I want ln of 1 plus x to the 4. So I'm going to substitute x4 for x. So I'm going to have, instead of x to the power 4. Instead of x, x to the power square over 2. Again, instead of x, x to the 4 over 3. Instead of x, x to the 4 over 4. So that's to give us the power series of that. And now in sigma notation, because as I said, I would ask you to do it both, to show me both on your exam tomorrow, to make sure that we can write it in sigma notation and without it. And this is going to give me is minus 1 to the n plus 1 times x. It's a 4 to the n over n, where my n goes from 1 all the way to infinity. Very good. Now, always the domain is something I always look at. The original one hold when the absolute x is less than 1. So if I substituted x4 for x, now the condition should be x4 to the power n in absolute value. Okay, the last step is we're going to write it in a decent way. We never keep it like this. It means we're going to do the algebra. So the algebra is the following. So ln of 1 plus x to the power 4 equals. So let me do the algebra. x4, nothing could be done about it. Minus. You never forget. x4 to the 2, we multiply the power. Give me x8 over 2 plus x4 to the power 3, again we multiply. And finally, x16 over 4, etc. So the sigma notation should become n equal 1 to infinity of minus 1 to the n plus 1 times x4 to the power n, again we multiply. It means x to the 4n over n. Now for which value the whole thing holds. Now here we're going to note that the absolute value, so note that absolute x to the power 4 is the same. I know we didn't prove that, we're just accepting it. So this condition becomes absolute x to the power 4 less than 1. It means the absolute x itself. The absolute x is less than. Okay? Any questions about that before I move on to the last problem from the homework?
Is it fine if we kind of skip that middle step where you wrote it, but then the second step you actually made the calculations? Is it fine if we just go straight to the calculations, or do we need to show that middle step?
Let me make sure. It means from here all the way to here?
Yes, because I seen how you wrote it, but then down here you just put the answer. When I did it, I just put the answer straight out.
This one you mean?
Yes.
It's up to you, as long as you don't do mistakes.
Okay.
Okay? It's up to you, but I don't want mistakes. All right?
It was just automatically when I seen it, I knew it was going to be like x to the 8th and x to the 12th.
Yeah, that's fine. That's fine with me. I'm doing it slowly because first I wanted to understand what I'm doing, and then I want to avoid mistakes. So if you're comfortable, you can do it all right. So keep as absolute value x4 less than 1. No, the answer should be in terms of x, not x to the 4. I want the condition on x by itself, not on x4. Okay? Any other questions? Great. So we're going to move on now to the last one, which is number 25, if my memory is helping. Okay. So number 25. Okay. So let me look at it. Evaluate the indefinite integral as a power series. All right, so this time we have the following. So I'm looking at number 25. Okay, yeah. So this is the integral of t over 1 minus t to the power 3 dt. sorry, c to the power 8. So it's t over 1 minus t to the power 8 dt. Okay, that's it. Again, one of those functions that none of our integration techniques will help us find the antiderivative. And the only way we can find the antiderivative of this function is basically by writing this as a power series and then integrating the power series. That's the only way. There is no other way to do that. So if you want an antiderivative of this, you have to express it as a power series. So how does this work? First, we find the power series of the term inside, and then we integrate term by term. Now, the one inside is not really hard because we've done this before, right? So do we now? So first we need to find the power series of t over 1 minus t to the power 8. That's going to be my first step. Once I do that, and then I integrate term by term and see where I'm going to head. All right, 1 over t over 1 minus t to the 8. So I want first 1 over 1 minus t to the power 8. Now, is this an easy series to find? Sorry, is this an easy function to find its power series? Yes or no? Yes? You agree with Sarah? And Christian? Okay, yes, so let us do it the way Jordan wants me to do it. So Jordan wants me to do the following. Let's say minus. It means there is no alternating going on. So it's going to be 1 plus t to the power 8. Am I right? You correct me if I am wrong. Plus t to the power 8 squared. I actually like to do that because I don't want to goof. Plus t8 to the power 3 plus t8 to the power 4 plus etc. So in sigma notation, that's t8 to the power n equals 0 to infinity. Okay? So this is equal to, and then I multiply by t across. So this is going to be 1 plus t8 plus t16 plus t24 plus etc. And in sigma notation, t to the power 8n, n equals 0 to infinity. And this is going to hold when the term I substitute by is less than. So we're almost there. So t, now I have t over 1 minus t to the 8. I have to multiply across by t. It means this is t multiplied by that. There is no way out. That's the way we're going to look at it. So I need to multiply this across by t and this one across by t. So this is going to be equal to, and here in sigma notation, term by t, t plus t to the power 9 plus t to the power 17, t to the power 24, etc. So in sigma notation is going to be t to which power? What's going to be the power here? When I add 8n plus 1, 8n plus 1, and that's absolutely correct. And the domain, for the same reason I did before, t has to be an absolute value less than 1. Wouldn't be the last one, t to the power 25? I trust you because, okay, that's why. All right, that's the power of the eraser. Thank you very much. Okay, so now we're gonna integrate and we're done. So we're gonna find the antiderivative, the power series for the antiderivative. That's all we can do. And so the integral will become, all right, term by term integration, term by term, term by term. The integral is of t over antiderivative of that is the term by term antiderivative. And this is not hard. It's a half t squared plus I will answer your question in 1 minute, Greg. All right, give me a minute. T to the 9 is what? What's the antiderivative? It's t to the 10 over 10. All right, t to the 17, t to 18 over 18, t to the 26 over 26, etc. Now, before I go on, I will answer the question to one of your classmates, and then I will proceed. Okay? So I'm going to talk a little bit more about the question concern why it's 8n plus 1. All right, so I'm going to back up here to answer this question. So when I do t over 1 minus t to the 8, it's t, so I will repeat this process, 1 plus t8 plus t16 plus t24, etc. All right, it means that's t times sigma, t to the power 8n from 0 to infinity. Okay, so I'll get back to the problem once I answer this because it's crucial that we don't do mistake. But now, this is equal to what? What am I going to do here? I'm going to distribute the t across. Okay, so I do distributing, that's t plus t9 plus t17 plus t25 plus etc. It means, what did I do at this stage? It means every term is going to be multiplied by t. So basically, what I'm going to do, what this is, it's sigma n equals 0 to infinity. Every term is multiplied by t. It means this is going to be a to the power n times t. Every term is multiplied by t. But now t to the 8n times t, what I'm going to do is at this stage you're adding the exponent. And this is going to give me t to the power 8n plus 1. Because now I am multiplying each term by t. So I'm adding 1 to the exponent. And it's going to give me 8n plus 1. Is the answer clear? Greg, is it making sense? Yeah, it's crucial. It's crucial. It's a good question, but it's crucial to understand it. So now I'll go back to the antiderivative. Where am I? I'm right there. Equal to. So I'm back to where we were. Sigma n equals 0 to infinity. The antiderivative. It means you're taking every term. So now we find the antiderivative in a general context. So basically, I am finding the antiderivative of t to the 8n plus 1. That's really what I'm doing. So mathematically, this is equal to what? What's the antiderivative of that? 1 over the general rule, sorry. It's 1 over the exponent plus 1 to the power the exponent plus 1. So that's to understand it in a very abstract way. It means that's 1 over 8n plus 2 t to the power 8n plus 2. So this is where this is going to give me. So the antiderivative of every term, so the antiderivative of every term here is going to be 1 over 8n. I'm going to add 1 to the exponent, t to the power 8n plus 2. And this whole thing will hold as long as my t is less than 1. Before I move forward, let me double check everything. So if n is 0, it's 1 over 2, t to the power 2, check. First term, correct. N equal to 1. Let's see if they match. 8 times 1, 8 plus 2, 10, t to the 10, match. So this is you make sure that whatever you're writing here and those agree with each other. N equals, so I did 0, I did 1, n equal 2. 8 times 2, 16, 16 plus 2, 18. So I am definitely on the right track. All right. Any other questions before I go to your review?
Do you want us to find the interval of convergence when we do these problems?
That's the interval of convergence. T has to be, so the interval of convergence, I don't want you in those problems to worry about the end points. Okay, so here, absolute T less than 1, it means it converges between -1 and 1. It diverges here. But for those typical problems, I will not ask you the endpoint. Did this answer your question, yes or no?
Yeah.
Okay, so for those problems, the interval of convergence comes from the theorem itself, because the theorem itself tells me that if you integrate, you keep the same interval of convergence as your original one, the one you start with. So you don't have to do it all over again. It means that 1 over 1 minus t to the 8 is going to converge when this is less than 1. It means this one will converge when absolute t is less than 1. That's the result of a geometric series. That's where this is coming from. The theorem tells me if you integrate and the new series you get will converge exactly when the old one does. It means it will converge when the absolute t is less than 1. So you don't have to do it all over again. You do it when you don't know. So this one, it means will converge for those value of t. In other words, if you do the work, if you take this series and you compute the ratio, n plus 1 over n in absolute value, and you find the limit, and you do everything you have to do for a regular series, you're going to get exactly this answer. Nothing will change. Okay? The endpoint, I repeat, you're not responsible for them in this kind of scenario. Did this answer your question? I hope. Yes or no?
Yes.
Yes. Okay. All right. Now, any more questions about the homework? All right. So now we're going to move to the review, and we go through them, and basically problem by problem kind of. But I would like your answers from the review because this is really helped me out a lot. So these are your reviews. As we move them, you guys tell me which one you had difficulties with and which one I can move on. So the first part is the part we did probably a while ago. You guys have the review with you. Mark wants number 2. Okay, we will set it up. We will set up number 2. All right, so the first part to really deal with the center of mass. So those problems actually mainly deal with knowing the formulas and apply it very well. So I will set up the formula for number 2. So please, I hope you guys have the paper, the review in front of you, so I won't have to rewrite the problem. So review now. Okay, and we look at number 2. So number 2, I gave you find the center of mass of the region which is bounded by. So I have 2 curves, y equal 4x minus x squared. And the other one is y equal x squared. And I have the region bounded by those. Okay, so first let us a little bit graph this. Y equal x squared is basically a parabola. And 4x minus x squared is a parabola going down. At 0, we are right here. At x equal 4, we are right here. And this is going to go basically this way. So this is the region that I am interested in. Okay, so we're going to set it up. I will not integrate. I know very much you guys know how to integrate because this is an easy one. So let us set up. So to be able to find the center of mass, I need 3 items. I need the mass itself, which is the density. So the density is constant times the area. Oh, so it means the density times the area. The area is, to find the area, I need this point and that point. It means we have to set them equal to each other so I can find the the intersection. So this is gonna give me 4x equal to x squared. It means 2x squared minus 4x equal to 0. So x times, so 2x times x minus 2 is 0, x is 0, and x is 2. So the intersection happened here at 2 and right here. So first, the area. The area is definitely, that's an easy problem. The area is the integral from 0 to 2 of the upper curve, which is 4x minus x squared, minus the lower curve, which is x squared dx. Okay, I will not compute. I will not compute anything. I will just set it up. Now, what is the moment with respect to what? And here the formula tells me it's the density times the integral from 0 to 2 of x times, that's the x, times the upper curve, which is 4x minus x squared, minus the lower curve. Then you find m1. Now, what is the moment with respect to x? And it's a half delta integral from 0 to 2 of the upper curve square, the upper curve squared, minus the lower curve squared dx. Okay, so and the rest is just computation, which I don't think, I'm not going to waste my time on it. So x bar, once you do that, is nothing more than divided by the total mass, and the density totally disappear, and y bar is mx over there. All right, and the rest is computation. The rest is really pure integrating, especially this one. This is an easy computation because it's nothing. It's a bunch of polynomials. So you basically simplify that. It becomes 4x minus 2x squared. Distribute the x and proceed. Here you have basically to do a little bit more algebra. All right, Mark, is that fine? Enough? Yeah. All right, so let me look at your other questions. And I go through them by order. So I have number 4C, that's the first one. Okay, 4C. So an equal, sorry, a sub n equal to n e to the minus n. Okay, now be careful. This question, they tell you find the limit of each of the sequence below. Do not confuse sequence and series. So I'm telling you this is a sequence. It means those are nothing more than bunch of numbers. I'm not adding them. I don't understand. Oh, sorry, D. Your question is C. All right. Okay, that's fine. You're right. I will look at C. But let me finish that. You're doing D, not C. Yeah, I know. I got it. I'll do C. Don't worry about it. So AN is there, but the thing I go back to it, do not confuse it with series. Here, I'm only interested in those as list of numbers. So at 1, it means I have e to the minus 1. That's the list I'm interested in. And so on. That's a list, not a series. All right, so what's the limit of that, since everybody doesn't want me to do this? I want the limit immediately. What's the limit? 0. I want immediately the reason. Immediately the reason. How would you do it? Very quick, because none of you want me to do that. In mute and tell me. Okay, I agree with you, Tim, but we wanted more. Yeah, exactly. You have to rewrite it as n over e to the n. That's the best way to do it. And now You can apply L'Hopital's, giving me 1 over e to the n, because numerator goes to infinity equal to 0. All right, now I go to see the problem that you guys want me to do. So the a sub n is -1 to the n times 2 to the n over 2n plus 1. That's, again, a sequence. That's just a bunch of numbers. And here, those numbers basically alternate because I have positive, negative. They do alternate, but I'm not adding them. I'm just looking at them as a bunch of numbers. So basically, let us a little bit list them, not because I have to, but to give you a feeling. So if n is 1, I'm going to have a 2, sorry, -2 if n is 1, over 3. If n is 2, I'm having 4 over 5, and if 3, I'm having -6 over 7, and this is really the kind of terms I have. So if n equal 100, for example, the term I'm looking at is 200 over 201. If n, I'm doing that on purpose, it's minus. If n is 101, it means minus 202 over 203, etc. All right, so that's really what I am looking. This is the list. So what is the limit? What's happening here? The limit does not exist. And why? Because those terms, ignore the absolute, the -1 to the n. Those terms become close to 1. No, no, no. I want just to find the limit. You don't have to write the terms. I write them to remind you what is the plus, what's going on. So 2n over 2n plus 1 becomes close to 1. It means those terms by themselves, without the sign, are becoming close to 1. But some are becoming close to 1, and some are becoming close to -1. It means that basically the series will diverge. So as I said several times, all the n where n is even are becoming close to 1. All the an where n is odd are becoming close to -1. For a sequence to converge, all the terms have to become close to a fixed number. So this series, sorry, this sequence diverges. Okay? All right. What was your second question? I'm trying to go up the chart to see. So 5 and 8C. 5, number 5, and number 8C. Okay. Number 5, I will look at it. That's actually number 5. All right. I give you a series. And I tell you that Sn always, Sn stands for the partial sums. That's what the Sn is. So I tell you, okay, I give you the series and I tell you Sn, it means the partial sum, is 3 minus n times 2 to the -n. So I just give you the partial sums. And my question is, find the sum of the series. Did I give you enough info? Yeah, that's number 5, right, Sarah? Yeah, okay. Now, did I give you enough information to find the sum of the series? If I say yes, if you say yes, justify. So I gave you the partial sums. It means, what did I give you? What is Sn? What's the partial sum? It means I gave you a1 plus a2 plus an. Is this enough information for you to give me sigma n? What's sigma n? What is the sum? Anyone? I don't get your answer. So what is sigma an? It's nothing more than the limit as n tends to infinity of the partial sum themselves. So if you know the partial sums, you know the whole sum, because what's the sum of the series? It's basically you look at the partial sums and you start adding them, and you ask yourself what happens when n becomes very large. So sigma an is nothing more than the limit of the partial sums. So now I have a formula for those. What's the partial sums? It's 3 minus, so that's my partial sums, and basically over 2 to the n. Okay. And the reason I give you those promises to remind you over and over that the sum is nothing more than you take the partial sums. It means you start adding terms, adding terms, adding terms, and you see eventually what happens when you add more and more terms. So that this is equal to that. Now, as n goes to infinity, you can use L'Hopital's rule here as well, and you're gonna get equal to 3. It means the partial sums become close to 3. It means sigma an itself is actually equal to 3. Let's tell me that, so this is number 7. Sorry. So this is gonna tell me that sigma an itself is equal to 3. Okay, so that's answered the first question. Now my second question was, okay, a bit trickier, but let's see if you guys can figure it out. So question is, can anybody give me a formula for an? Was anyone able to find? Anyone? Anybody has any idea? Absolutely correct. What is an? Suppose I take Sn. What is Sn? It's a1 plus a2 plus etc. The last term is an. That's the definition. And then if I look at the first up to here, so what's the relationship? Sn is nothing more than Sn minus 1 plus an. So what is an? It means you add all the term up the nth term, and then you take away the sum before it. With this in mind, I know what my an is. Sn is 3 minus n over 2 to the n minus 3 minus n minus 1 over 2 to the n minus 1. So it's a little bit, it's not a hard question, but it's a little bit different. So this is going to give me 3 minus 3 cancel out, minus minus plus, n minus 1 over 2 to the n minus 1. And the rest, you do a little bit of algebra. The common denominator is going to be 2 to the n. So finally, you're going to get minus n plus 2 times n minus 1 over 2 to the n. So that's algebra at this stage. And you get the answer. So minus 1 plus 2n, it's in n minus 2 over 2 to the n. All right. Okay, so let us move on. It's number 8. The question is number 8. Which one in number 8? Okay, for those who ask number 8, let me back up. Sorry. 8C. All right, so I look at 8C. Oops. So 8C. All right, 8C. Sigma 1 over n plus ln of n. And n equal 2 to infinity. All right, and does the series converge or diverge? What do you think? Which test do you think is a good test? Divergence test. Let's see. My AN here is 1 over n plus ln of n. When n goes to infinity, AN goes to where? What does AN goes to? When n becomes very large, it goes to 0, no conclusion or whatsoever. All right, so nothing. If the limit of the AN is 0, the series may converge or diverge, so no info. So what do you think will be the proper test? Okay, integral test. Okay, you have to integrate. And how to integrate 1 over, you have to integrate 1 over x plus ln of x. I don't know how to do it. It's a very hard integral because it's a plus. So there is no substitution in the picture. So if this is a plus, substitution is gonna fall apart. So what are the other possible tests? So integral test requires integrating x plus ln of x, that's hard. So we have the limit comparison test and the ratio test. Limit comparison test, sorry, the ratio test will give you 1 in this scenario. This is because there are no powers of n, there is no factorial. That's where the ratio test is going to give me a problem. So I'm going to use the limit comparison. But I'm going to compare it with what? That's going to be the issue. So 1 is 1. The denominator, exactly 1 over n, because when n is large, ln of n, and I've talked about that plenty, is goes to infinity way, way, way slower than n. So what really gonna take over here is the 1 over n. And I have to use the limit comparison test. Now, when I use the limit comparison, I have to make sure that I am comparing it correctly. It means an over bn is actually something, not a 0 number, and not goes to infinity. So I always compare. I cannot say because, so I compute the limit of an over bn. And I make sure that the limit is not 0 or not infinity. So an over bn, an is 1 over that, bn, so I'm going to have n over n plus ln of n. And I have to compute this limit. So this is equal to, when n becomes large, you can use L'Hopital's rule if you want, or you can divide by n. So let's use L'Hopital's rule because it's fairly easy. The derivative of the numerator is 1, and the denominator is 1 plus 1 over n. This is equal to 1. It doesn't have to be 1. 2 is okay, 5 is okay. What matters is you don't have a 0 or infinity. And now the limit comparison test could be used. So now limit comparison test applicable. When I say applicable, I mean you can apply it. Now sigma bn diverge, then the limit comparison test will tell me that this one diverge. Okay, so that's how we have to handle this problem. Every other test will be actually the ratio test, which is the best, which is the easiest test, will give you a 1 in this scenario. And the ratio test fails when it is 1. So the best way to do this particular problem is actually the limit comparison test. All right? Okay, you guys, I know that time is up, but if you guys have any other questions, I can answer one more question. I don't know what you guys have here. 6, 5, 6A, and 7. What 7? 7. All right, I look at number 7, and then I will go to my office hours, and you guys can join me there or quit. It's up to you. So 7 was about the bouncing ball. Yes, Adam. Remind me to talk. I will look at 7, and then I will talk about the exam. I forgot about that. So number 7, you have a ball, and that's what happened to the ball. The ball is dropped from a height of 100 feet. So this is the ball, we drop it 100 feet. Okay? And then what will happen after that? And each time it hits the floor, it rebounds to 2/3 its previous height. So this ball is gonna hit the floor, and then it goes 2/3 of what it was, and then back up. So that's 2/3 of 100. And then it is the floor again. This time it goes 2/3 of what it was and then bounce back. That's what it does. And then again, it starts here, 2/3 of what it was and bounce back. And it keeps going. And so it keeps going forever. Imagine there is no friction. It keeps doing this forever. And the question is, find the total distance it traveled. All right, we're going to do it the easy possible way. What's the total distance? First, it's 100. It doesn't rebound because you're dropping. And after that, what happened? The distance is 2/3 of 100, which it means 2/3 times 100, but it's twice that much because it goes up and then bounce down. So it's 2 times the 2/3 of 100 plus. Now it goes 2/3 of what it was. It means 2/3 of the 2/3. It means 2/3 squared times 100. But it's twice that much because it rebounds. It keeps going like that. 2/3 of what it was, and then the 2 from the rebounding, and it keeps going. So that's the formulation for it. Now we have to compute this sum. Now, it doesn't look, so let us compute. It looks like geometric because every time what I am doing is basically multiplying by 2/3 because every time I'm taking the 2/3 of the previous one. That's really what's happening. Every time it's 2/3 of the previous one. So this looks like a geometric, but not from the first term, which makes sense because at the beginning, I'm not letting it go up and down. So it's going to be equal. The first term is going to be off. It's going to stay by itself. And then after that, I'm going to compute the sum. So one way you can, if you want, you can factor out the 2. You don't have to, but you can factor out the 2 because it's clear 2, 2, 2, 2, 2. And then I will be left with 2/3 times 100 plus 2/3 squared times 100 plus 2/3 cubed times 100 plus etc. So finally, I am at the end of it. That's 100 plus 2 times. This is a geometric series. The ratio is 2/3. So it's definitely going to converge. And what's the sum of the geometric series? It's the first term. That's first term times 1/1 minus the ratio. The ratio in this case is 2/3. So finally, I do the math and it's going to give me 100 plus 2 times 2/3 times 100 times, it's going to give me 3 minus 2 times 3. So finally, 3 and 3 cancel out. I have 100 plus 400. That's going to give me 500, whatever the unit, which is feet in this case. Okay. Any other questions? You guys can meet me in my office hours right now. I'm moving to the office hours. So if you have, I can work with you during my office hours if you have any questions, so please do. Now, as far as the exam is concerned, the exam will be on Blackboard. So at 10:50, it will be there. So I'll give you like 10 minutes to print your exam and stuff like that. So it will be on Blackboard at 10:50, and I will 11, so it's 12. I'm gonna view all the time you want. 12:45, it will be taken off. It means you have to submit by 12:45. Now, during all this period, between 11 and 12:45, I will be on Zoom. So I want you all to connect to Zoom, be there. Yes, 12:45 our time. But the Blackboard will show 1:45, because as I told you once before, Blackboard is West Lafayette time, not our time, okay? That's the problem. So you guys know it. Now, I want you to connect to Zoom, of course, in mute and everything. I will be there. So it means I will be basically in front with you. And if you have any questions during the exam, you put on the chat. Is that very clear? So I will be all the time with you, and you guys will put all your questions on the chat. So like regular class, but I'm not physically present and you're not physically present. But I will be with you. So it's not like, I'm leaving you during the exam. I will be there. You ask your question that has to be asked privately with chat. If there is an issue that the whole class have to know about, then I will send a message to everyone. All right, any questions before I move on to the office hours? Yes, definitely, because I will not, you're at home. I'm not monitoring you, so I will not, I'm not going to tell you don't use the notes. I will be lying to myself. Then the answer is yes. You can reference the notes. Any other question? Okay, so good luck for tomorrow. Anybody has any question, please join me in my office hours right now. Good luck, guys.
Question.
What? Yes, Jordan.
Will you be having your office hour in the morning like you usually do, or no?
Everything is like usual.
Okay.
Nothing changes. All right?
All right.
Anything else?
Thank you.
Oh, sure. Anything else? Okay. Bye-bye, guys, for now.